Okay, grab your notebooks and let's dive right into this exam case file. Welcome to today's Explainer. I'm going to be your lead detective for this session, and we are stepping directly into the gritty, highly analytical world of Cambridge AS and A-level mathematics. Specifically, we're tearing open syllabus section 3.9. You see, the difference between a B and an A star in math often comes down to one thing: how well you truly understand the Cartesian form of complex numbers. We're going to treat these past papers not just as standard tests, but as intricate crime scenes packed with hidden forensic clues. Today, our primary target is the Cartesian form, X plus IY. And let me tell you, if you don't deeply understand the real part, X, and the imaginary part, IY, you are basically walking blindfolded into a forensic minefield. This whole thing? It isn't just about memorizing some formulas off a textbook page. It's about building a bulletproof, mathematically sound case from the ground up, a case so solid that it leaves the examiner absolutely no choice but to award you maximum marks. So, let's get to work.
Looking at our evidence board for today, we're going to cover the crime scene investigation, our forensic technical methodology, the interrogation debate, profiling, top examiner warnings, and finally, case closed.
Section 1. The crime scene investigation. Let's open the file.
Right, so the absolute crucial point here is that mastering this specific Cartesian definition is your foundational footprint at the scene of the crime. Let's really examine the anatomy of our primary suspect, Z equals X plus IY. Now, this isn't just a single number, okay? It is a composite entity. It's got layers. The X represents the real part. Think of that as the tangible, concrete evidence you can physically hold in your hands at the scene. Then you have the IY. That's the imaginary part, where I is the square root of -1. If you picture the Cartesian plane, or the Argand diagram as we call it in this context, think of it as the physical map of our crime scene. The x-axis, that's the main street. The y-axis, that's the dark alleyway intersecting it. If you're only tracking the real part, you are literally missing exactly half of the spatial coordinates needed to locate your suspect. The entire theoretical architecture of Section 3.9 rests on these incredibly precise definitions and the causal relationships between them. Actually, if you misidentify X or Y right out of the gate, your entire chain of evidence is completely contaminated. There's no recovering from that.
So, what does it take to secure the top tier? The secret to unlocking the A-star marks lies heavily in cross-topic connections. Official principal examiner reports explicitly highlight this. They tell us that candidates who reference cross-topic connections and apply their conceptual understanding to totally unfamiliar contexts, those are the ones who secure the highest marks. You see, the A-star candidate doesn't just look at X plus IOY in a vacuum. No, they connect the forensic dots. They realize that complex numbers are intimately tied to solving quadratic equations that have no real roots. They see the underlying links to polynomials, to trigonometry, to geometric representations on that Argand-Jiggum diagram. When you step back and integrate this Cartesian form with other areas of the syllabus, you elevate your response from a basic, low-level incident report to an absolute masterclass in forensic mathematics. You've got to show the examiner that you understand exactly how the weapon, the motive, and the opportunity all link together across the entire math syllabus.
Moving on to Section 2, forensic technical methodology.
When you are tackling these past paper examination questions, you must, and I mean must, follow this standardized forensic sequence to the letter. Consider this your survival guide in the exam hall. Step 1. Deconstruct the question. What is the actual command word? Are they asking you to evaluate, show that, or solve? Those words change the whole investigation. Step 2. Extract relevant data. You need to isolate your X and your I values from all the extra noise and fluff in the question. Step 3. Select the analytical framework. Are we equating real and imaginary parts here, or are we calculating a modulus or an argument? Make a choice and stick to it. Step 4. Execute with clear notation. Guys, this is where sloppy detectives ruin their own cases. If your I looks like a 1 because you're writing too fast, or if you drop a negative sign while expanding brackets, boom, your logic string snaps. Case dismissed. And finally, Step 5. Present with correct terminology. Call it the imaginary part, not just the Y bit. Following these 5 precise steps ensures your analytical framework is completely robust and ready for the roughest cross-examination by the examiner.
Listen closely, detectives, because this is vital. In Cambridge Mathematics 9709, the final answer is really only the tip of the iceberg. The method mark strategy is your ultimate safety net. Let's say you make a tiny, minor arithmetic error back in Step 2. It happens. But if you have clearly documented your procedural framework, if you've shown the examiner exactly how you equated the real parts and the imaginary parts, you will still pick up method marks for all the subsequent steps. The examiner is literally awarding you points for the process of your investigation, not just the final conviction. Look, if you just write down an answer with zero working, it's exactly like presenting a murder weapon in court without an evidence tag. The judge is going to throw it right out. You have to document every single step.
And speaking of documenting, if you want to build a truly bulletproof case, your presentation of information must strictly adhere to specific analytical conventions. Imagine handing over a critical evidence file to the district attorney, and it's just a disorganized stack of unlabeled, coffee-stained papers. That is exactly what a messy mathematical proof looks like to a Cambridge examiner. You've got to use proper headings, you must use correct terminology. If it's a complex conjugate, call it a complex conjugate. Use appropriate formats, meaning leave your final answer explicitly in the form X+iy if that's what the search warrant requested. And clear annotation is huge. If you're substituting one equation into another, literally write substituting equation 1 into equation 2. Guide the examiner through your mind step by step. Make it practically impossible for them to misunderstand your logic.
Let's move to Section 3, the interrogation debate.
Okay, let's step into the interrogation room and analyze where candidates typically crack under pressure. We're going to look at two very flawed suspect profiles, Agent Alex and Agent Sam. First, you have Agent Alex. Alex operates purely on a descriptive level. This happens when a candidate gathers massive mountains of raw facts, basically copying down long blocks of textbook definitions about what a complex number is, but entirely fails to build a coherent case motive. They don't link any of those facts to the specific question, and they completely fail to identify relationships. Then, on the other end of the spectrum, we have Agent Sam. Sam is all about that rushed, analytical level. Sam jumps to immediate conclusions. They look at a complex equation, guess the roots based on gut instinct, and just write them down without justifying any of their decisions using clear algebraic evidence. Here's the truth. If you act like Agent Alex and rely solely on descriptive facts, your logic string collapses because you didn't actually analyze the scene. If you act like Agent Sam and skip the justified reasoning, you score 0 because you skip the vital forensic confirmation steps. Your goal? Find that perfect middle ground. Rigorous, completely justified analysis.
You see, higher-order assessment objectives demand that you elevate your working. You have to move up from purely descriptive statements to a fully evaluative argument. This table right here, this is the literal DNA of the marking scheme. At the bottom, we have the descriptive level. This is basic knowledge, like knowing that I squared equals -1. It's necessary, sure, but it is not going to get you an A-star. In the middle, there's the analytical level. This is where you apply the X+iy form to totally unfamiliar contexts, like solving a tricky quartic equation where the roots happen to be complex conjugates. But the very top tier, the evaluative level, that is where the master detectives live. Up there, you question assumptions. You proactively verify your roots. You justify every single algebraic leap with concrete mathematical evidence. You're constantly evaluating the quality of your own working as you go, making sure no logical fallacies have contaminated your proof.
Case file freeze. Before we reveal the structural framework to help you clear your upcoming Cambridge sessions, make sure your intelligence feed is secure. Take a second right now to subscribe to Ace the Exams at the handle @AceTheExams and turn on all notifications. You do not want to miss our weekly forensic exam updates, whether you're cracking cases at IGCSE, O-levels, or AS and A-levels. Okay, back to the case. Top-scoring candidates master the evaluation by supporting each comparative analysis with hard mathematical evidence. To do this, you need a structural framework. Think of it like the Peel matrix: point, evidence, evaluation, and link. You state your point, you provide the algebraic evidence, you evaluate its limitations, and you link it right back to the Cartesian form requested. For example, if you are dividing two complex numbers, your evaluation must recognize that leaving an I in the denominator is a strict violation of mathematical protocol. You have to multiply by the complex conjugate to rationalize it. Drawing conclusions about the relative importance of these steps and executing them flawlessly, that is what separates the rookies from the lead detectives.
Let's look at Section 4, Profiling Top Examiner Warnings.
Official Cambridge intelligence reveals there are exactly 3 fatal mistakes that candidates make over and over again when dealing with the Cartesian form of complex numbers. These are the hidden traps that completely ruin otherwise perfect investigations. We've scoured the principal examiner reports, analyzing the forensic data of thousands of past candidates, and honestly, it all boils down to these 3 catastrophic errors.
Misinterpreting these core parameters acts exactly like a fingerprint match error. It instantly throws out your easy case marks. Let's review the bulletin board here. Warning number 1, forgetting to include the proper format. Look, if the question explicitly asks for the answer in the form x plus iy, and you leave it as a messy fraction with a complex denominator, you lose the final mark. It is literally that simple. Warning number 2, forgetting to check format and presentation. This ties right back to what we said about clear annotation. If your real part x and your imaginary part iy are all jumbled together on the page without clear separation, the examiner cannot verify your results. Warning number 3, and this is the big one, providing answers that are not specific to the given context. If you're analyzing a geometric locus in the Argonne diagram and you just give a purely algebraic answer without relating it back to the specific circle or line mentioned in the scenario, your evidence is totally inadmissible.
I want to read this direct quote straight from the official Examiner Intelligence channels. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." End quote. Guys, this means you absolutely cannot just memorize a sequence of steps from a textbook and blindly paste them onto the exam paper. It doesn't work. Every single past paper question is a unique crime scene. If the scenario involves finding the square root of a complex number, you must set up the equation a plus ib squared equals x plus iy. Expand it carefully and explicitly equate the real and imaginary parts. A generic answer completely devoid of context destroys your overall mark integrity.
Finally, Section 5. Case closed. Let's audit our final evidence. Before you even think about dropping your pen, you must interrogate your own evidence quality. Confirm you haven't left any unverified alternative interpretations hanging around. I want you to perform a visual clue scan on your own exam paper. Imagine a 60-second digital countdown timer running on the screen right now. Look at your final paragraph, your final block of working. Did you extract the single highest-yielding core trend? Try to find the counterfeit answer within your own writing. Is there a line where you randomly dropped a negative sign? Is there a sentence of descriptive fluff that adds absolutely zero analytical value? You have to act as your own worst interrogator here. Take a mental digital marker, isolate any discrepancies, and correct them before the examiner ever gets a chance to see them. Verify that every variable, every x, and every I is linked right back to the original crime scene scenario.
Now, to ensure you don't drop the ball when the pressure is on, you need to build a quick mnemonic for the x plus iy components and those methodology steps. When the exam clock is ticking down and the adrenaline is spiking, you need a reliable mental shortcut. Remember the technical methodology we discussed earlier. Deconstruct, extract, select, execute, present. DESEP. Think of it as detectives examine scenes experiencing pressure. Or hey, build your own specifically for the complex conjugate rationalization process. Whatever it is, lock it deeply into your memory banks. This memory hack acts as your tactical gear, ensuring that even under severe exam conditions, your procedural framework remains rock solid and your presentation conventions simply do not slip.
So, let's do a final recap of our evidence board. You need to secure those cross-topic connections. Lock in the method mark strategy by showing all your working. Question your assumptions with high level evaluative thinking. And never, ever use generic, out-of-context answers. Mastering the Cartesian form x plus iy isn't just about memorizing rules. It's about deeply understanding the spatial and algebraic limits of a two-dimensional number system. But I want to leave you with a provocative thought. If I allows us to find roots for literally any polynomial, what happens to our forensic methodology when we step into three-dimensional, hypercomplex numbers like quaternions? Does our logical framework hold up, or does the whole thing just break down? Keep investigating that one on your own. Make sure your intelligence feed is secure by subscribing to Ace the Exams at Ace the Exams. Click that notification bell for our weekly grade masterclasses. And right now, drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O, AS, or A-level, you are preparing to conquer next. Case closed.